Hey boys and girls, for the next 2 weeks, we are going to be studying water. And you might be thinking, how can we spend 2 weeks studying something as simple as water? Well, I will tell you, water is actually incredibly complex. The chemistry behind it and how it works is amazing. It's very clear that God perfectly designed water for what it does, which is support every single living thing on earth. Everything that's alive here on earth depends on water. And so we're going to look at this mighty liquid that is so incredible. It's really a miracle. And we're going to do hands-on things each day. So before we get into that, I'm going to go ahead and just do a quick overview of an introduction to chemistry for you, just give you a little background as we study this. And you do have a worksheet that you'll fill out with little bits of information each day as you watch these videos. So first of all, when God created the universe, he divided it up into two main categories. We have matter, solids, liquids, and gases, and we have energy, things like electricity and heat and light and sound. Now, energy is its whole own separate topic. When we look at things like heat and light, those work differently, and we'll study more about this in 5th grade in physical science. But when we take a look at matter, everything that's a solid, a liquid, or a gas that is in the universe, it is made up of these teeny little particles called atoms. And anything that's a solid, a liquid, or gas has these different little particles in them called atoms. Now, the pictures that I'm showing you here, these are taken with a very special microscope called an electron microscope, and it can show you some different atoms. To give you an idea of how small these are, if you were to think about your pencil point, on your little pencil point, there's about 10,000 of them in just that little tiny point of lead. So they're incredibly small. Now, of course, since we have so many different kinds of materials, so many different things and types of substances around the universe, there's not just one kind of atom. In fact, we have what's called the periodic table of elements, where we list all the different kinds of elements, all the different kinds of atoms that God made. You might have seen this thing before. Elements are all those different kinds of atoms. So for example, we have oxygen atoms and helium atoms and aluminum atoms and magnesium atoms and lithium and hydrogen. Those are all different kinds of atoms. We call those different kinds of atoms elements. And as you get into more advanced science, you'll study more about this periodic table of elements that talks about all the different kinds of atoms that we have. And each atom does special things. Helium acts differently than oxygen, which acts differently than copper. And each one of those elements has a special characteristics of it. Now, atoms aren't usually hanging around by themselves. They can, but most of the time atoms like to team up with other atoms and stick together. When atoms stick together, we call those molecules. So one of them by themselves is called an atom, but most of the time they're stuck to other atoms and we call them molecules. And they can stick to other atoms of the same kind. Like here's an oxygen molecule. So there are two atoms that are the same kind, oxygen, and they're stuck together. But a lot of times they mix together with other atoms to make new types of materials. And so you can see a couple of them here. We have a water molecule, a salt molecule, and then this is what sugar looks like, a glucose molecule. So they can get really complicated. In fact, some of the different types of plastic molecules that we have literally have thousands of different atoms stuck together. So they can be incredibly complicated. The study of all those different types of atoms, by the way, is called chemistry, and it can get really complicated. Today, though, we are just going to take a look at this one particular molecule, a water molecule. That's what it looks like. And a water molecule is made up of 3 different atoms. 2 of those atoms are hydrogen atoms. That's the kind of element it is. Hydrogen, yes, that's like a gas, that's explosive. And then the other type of atom that's in it is an oxygen atom. And oxygen is what we breathe. It's also a gas that's in the air. So when we talk about water, that's what a water molecule looks like. We often refer to it by its chemical formula. And this is just an abbreviation for it, a shortcut way of writing it. So since there are 2 hydrogens, we use the abbreviation for hydrogen, which is an H, capital H, And then we put this little number 2 next to it because there's 2 of those atoms in one of these molecules. And then the other atom that's in it, like I said, is an oxygen atom. So we include an O, that's the chemical abbreviation for it, and we include that as well. So you'll often hear water referred to as H2O, and that's the chemical formula. It's just the shortcut abbreviation that chemists use, and it tells us that water is made up of 2 hydrogen atoms and 1 oxygen atom. And what's kind of cool if you think about it is that hydrogen is a gas by itself, and oxygen by itself is a gas too, but when we combine them together, we get a liquid. Like I said, it's kind of amazing how complicated chemistry can get and how cool it is that God arranged all of these to just work together perfectly. Anyway, that's the molecule that we're going to be focusing on for the next 2 weeks. And you'll see it written like this. You'll also see it appear like this, where you can see actually have the H's and O's labeled on the different atoms. And then sometimes you'll see it as a stick version of it, where there's like the little bonds where they're stuck together are drawn with little sticks as well. So that's what we're going to take a look at. Now, as we study this molecule, the first thing we're going to take a look at is what happens when water freezes. That's going to help us understand the rest of the things we're going to study with water. So if you have the materials at home, you can go ahead and do this experiment with me. I'm using a long, skinny container, in this case a vase, but anything that's on the longer, skinnier side would work well for this experiment. So I've got a vase here, and then you're just going to take some water. I'm going to go ahead and pour it into my vase. And it really doesn't matter exactly how much I put in there. But what we're going to do is we're going to freeze this water overnight. And what I want to do is see what happens to that water as it freezes. So I'm going to take a Sharpie marker. It will come off, don't worry. Sharpie marker is the best way to mark it. Or you could use a piece of tape or a string or something and tape it on there. But what I want to do is mark what the water level was when I went ahead and put it into the vase. So again, it doesn't matter how much water it is, but the point is that I'm going to take my Sharpie marker and I'm just going to draw a line where that water level is. And then I'm going to stick it in the freezer. I'll leave it in the freezer, lay it flat in the freezer overnight. And in the morning, you can open it up and see what it looks like and see how it compares when it's frozen to when it was in the liquid phase. See you tomorrow.